Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Science Alert. This should be entertaining. Lost piece of Mars found on Earth reveals an ancient volcanic secret. Interesting. An unexpected tool is giving us new insight into the fine structure of the outer layers of Mars. Now, using meteorites that were long ago chipped off the red planet around 11 million years ago and flung into space to eventually land on Earth, scientists have been able to study the way volcanism shaped the crust and mantle of Mars to infer the presence of silicate reservoirs that fed their formation. That's interesting. I'm not a scientist myself. Any volcanologists out there, please feel free to drop a comment down below the video. And I'll leave the link to the main article below the video as usual, so you can pop in and check out these embedded links if you want to go for a bit of a deeper dive. It's just, makes for an interesting read. So if there's any planetary geologists out there, please feel free to comment because we'd love to hear from you. It'll be awesome. Thank you. Now, it's quite a crafty bit of research, really. We have new information about the structure and the evolution of Mars without having to go all the way there to get it. Yes, Martian meteorites are turning out to be quite an asset for understanding the planet's history, and they're delivered right here to our own doorstep. Martian meteorites are the only physical material that we have available from Mars, says geologist James Day of the Scripps Oceanography Institute. They enable us to make precise and accurate measurements and then quantify processes that occurred within Mars and close to the Martian surface. They provide direct information on Mars's composition that can ground truth mission science like the ongoing Perseverance rover operations taking place there. Look at this, a piece of the Nakla meteorite, and that's from the Scripps Institution of Oceanography in University of California, San Diego. Yeah, it's that there's a theory about how life came to Earth, and that was panspermia, which is when, asteroids, meteorites, whatever, again, I'm not a scientist, so please feel free to correct me on this. They would come to Earth, the necessary ingredients of life. They mixed with our primordial ooze, and this is how life started. Same way that they got there, there's these life-bearing materials the same way these rocks go here. So if Mars was volcanically active 11 million years ago, blink, bits were thrown off the planet. Must have been a hell of an explosion. Seriously, it must have been massive to shoot stuff into space. That's just incredible. Again, I don't know a lot about it, but I'm just imagining what sort of volcanic eruption you'd have to shoot something out into space. Incredible. Now, the meteorites examined by Day and his colleagues come in two forms. Now, chassignites, after rock found in 1815 in Chassigny in France, and Naklites, after a specimen uncovered in Nakla in Egypt in 1905. Now, the two kinds of rock also have different compositions. Naklite is basaltic, containing, not a geologist, as I say, still love geology though, containing inclusions of the minerals augite and olivine. Chassignite is almost entirely olivine. Here on Earth, basalts are more abundantly in the crust, and olivine is more abundant in the mantle. Mars is no different. And there is a piece of Chassigny meteorite measuring just 0.5 millimeter across. Wow, that's from the Scripps Institute of Oceanography, University of California, San Diego. Fascinating. I wonder if anything erupted from Earth and went to another planet. I wonder if there's maybe there was life on Mars, a long time ago, and they found a bit of Earth meteorite. That'd be interesting to think of somebody else doing it too. Now, by conducting a careful examination and comparison of the two kinds of rock and their unique chemical characteristics, the researchers are able to determine that they were formed in the same volcano around 1.3 billion years ago. Their difference is due to a process called fractional crystallization, which is when differing conditions cause the liquid magma to harden into different configurations. Wow. Interesting. The Nakalites were part of the Martian crust. The Chassignites were part of the mantle below. Moreover, some of the Nakalites were close enough to the crust to interact with and become altered by the atmosphere of Mars. Wow. By determining that Nakalites and Chassignites are from the same volcanic system, and that they interacted with Martian crust that was altered by atmospheric interactions, we can identify a new rock type on Mars, Day says. Now, with the existing collection of Martian meteorites, all of which are volcanic in origin, we are able to better understand the internal structure of Mars. Interestingly, the two rocks show that volcanism on Mars is both similar to and different from volcanism on Earth. The fractional crystallization seems to take place the same way, forming basalt-dominant rock in the crust and olivine-dominant rock in the mantle, just like volcanic activity here at home. Now, on the other hand, the reservoirs on Mars are extremely ancient, separating from one another shortly after the red planet was formed, Day says. On Earth, plate tectonics has helped to remix reservoirs back together over time. Now, in this sense, Mars provides an important link between what early Earth may have looked like from how it looks today, and the research was published in Science Advances. Absolutely amazing. Absolutely amazing. As I say, not a geologist, but I love it. And this is really great because we can, as I say, we can find out what was going on the surface of Mars and learn, the differences between planet types and everything else. So, volcano types on planets and all that sort of stuff. And the fact that this has flown all the way from Mars is absolutely incredible to me, As I say, it's like the old panspermia theory about, life-bearing molecules or, whatever was necessary to trigger life on Earth, and it probably would have come in the same way. I wonder if it did come from Mars. That would be very interesting. Love to hear your thoughts on that. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
I'll be back.